Hello again, students. We got example 3 from the 4-2-4-4 notes. We're going to graph y equals x squared minus 5. So as you can see, I've already chosen my 7 inputs. When you have these little exponents, they're called quadratic functions. Spoiler, they're going to be nonlinear. Okay, so fun fact. When you have these ones, you want to have a bit more than 4, 5, or 6. So 7 corner points, you're going to get a really nice picture here with these nonlinears. You want to get a few more corner points with nonlinears because you really want to see the pattern that they create. So here we go. So I picked -3 to +3. This is kind of like a super home base. So on example 1 and example 2, we did -2 to 2. There's -2 to 2 for our inputs. -3 to 3 is like the super home base numbers for your inputs. So again, what are we doing? These values are going in, these values are coming out, and then together they make corner points, and those corner points make the graph. So we got to make this table filled in. Here we go. We have an x squared minus a 5. Now remember, it's best practice. We've talked about this for a while now. It's absolute, super duper, crazy important that you use brackets when you square inputs. If you don't use brackets, you're going to square negatives wrong, and if you square negatives wrong, you're going to get wrong numbers, and then your graph is going to be wrong, and then you just get everything not correct. So again, make sure you take your time. I'm going to go all of the inputs one at a time. Make sure you use brackets when you plug in your values, especially the negatives. That way all of your calculations are done correctly. All right, so then we're going to go -5 to all these. Take your time, write this out. If you need to pause the video, copy it all down. That's totally an option. Trying not to have my penmanship be too bad here. Okay. So now I gotta do all this math. -3 squared is actually a 9, and then 9 minus 5, I believe, is 4. All right, I got my calculator ready to go to back myself up just in case. Kind of running on fumes right now. -2 squared is 4. 4 minus 5 is -1. -1 squared is 1. 1 minus 5 is... No, it's not. It's +1, silly goose. There you go. Come on, brain. +1 minus 5 is -4. 0 squared minus 5 is -5. 1 squared is 1. Minus 5 is -4. 2 squared is 4. 4 minus 5 is -1. Oh, there's something kind of weird happening here with our outputs. Interesting. 3 squared is 9. 9 minus 5 is +4. Okay, so here's our ordered pairs. I'm going to put all the commas down the middle, and I'm not going to copy the parentheses. It's just kind of a waste of time. Okay, here's all my inputs. I plugged in a -3, I plugged in a -2, I plugged in a -1, I plugged in a 0, then a 1, then a 2, then a 3. And then I got a 4, then I got a -1, then I got a -4, and then I got a -5, and then a -4, then a -1, and a +4. All right, so we have a bunch of corner points to plot. Let's take our time and plot them carefully. -3 and 4. -3 is 3 to the left, up 4 is going to be right there. -2 and -1 is going to be 2 to the left, down 1. Okay. -1, -4, 1 to the left, down 4. 0, -5 is going to be freeze, down 5. 1, -4 is 1 to the right, down 4. Ooh, looks like we're kind of looping back up. We kind of looped down pretty quickly, and it kind of slowed down. See how the points are kind of closer here? They're kind of slowing down a little bit, so to speak. And we have 2, -1. 2, -1 is right there. 3 and 4. 3, 4. Here we go. Oh boy, it's kind of like a little bowl, like a little curve here. So we'll get into more of these in the future, but these are actually called quadratic equations. The graphs are called parabolas. So that's kind of a little fun thing we'll talk about in the future, but they kind of go like this, and I'm really not good at graphing these by hand because they're curved. I'm not even that good at drawing straight lines, so I'll try my best here. All right, so we're going to start up right about here, like so, and then we're going to come down, hit that spot right there, and my palm is kind of sticking to the paper, so it's not really flowing very good. Oop, there we go, we're doing okay. There we go, I'll take it. All right, that's not bad. That's probably one of the best ones I've ever drawn before. All right, so like we said, this is nonlinear. Why is it nonlinear? Because it's curved. It's not a straight line. If you're linear, you make a straight line. If you're not linear, then you do not make a straight line. All right, so some fun things about this one. Again, look at this -5 right here. There's a -5 right there on our y-axis. The y-intercept is -5, and there was a -5 in our equation. Interesting how that works out. Like I showed you on the last example, you can do this a bit more efficiently if you go to y equals, and then you type x squared minus 5, you type in your function, and then if you go to the table, wow, look at that. I did this ahead of time, so I'm sorry, it's not really that cool. But I took my 7 inputs, already put them in, and there's my 7 outputs. So you can use the calculator to check your work by hand, and you can do things a lot more efficiently. So anyway, just using the technology to back up what I can do with my skill sets. That's about it for example 3. Inputs, calculated, outputs, inputs, outputs together make the corner points make the lines, and then with the curved line, just sketch the best you can, and then try to make it as pretty as possible, but we're not grading you on your art ability. Just try to be as accurate as you can. All right, we'll see you on the next one.